Hi, welcome to Think Human. I'm Chris, and in this video I want to talk about nuclear fission and nuclear fusion. What are they? So currently around us today in this world we have nuclear fission is the most popular one. So every nuclear power plant we have that's producing electricity is working on the principle of nuclear fission. And this is when you have a large atom and you break it into smaller parts by nuclear fission, and you can have this contained chain reaction going on that releases energy. And indeed, you can get energy by splitting atoms, and this is exactly what we do. We take something really radioactive, something large, an atom like uranium, and then we shoot neutrons at it and to split the atom apart, and this produces more neutrons, splitting other atoms apart and producing energy and heat, and to drive generators and turbines and to make electricity. This is how it works. Of course, an enormous problem is the actual nuclear waste. We have tons and tons of it just sitting in fields and nothing actually done with it. There is a site to properly take care of this waste built in Finland, to actually go deep underground and put this there, so no one will get to it. We can seal it up, it will stay there and not cause any harm. More interesting thing is actually nuclear fusion, and this is experimental that we're working on. We definitely know it's possible. Why it would be good, much better way, is it releases about 3 to 4 times more energy than nuclear fission, and it's much safer. It doesn't produce waste. Essentially what it needs is water to run, hydrogen. What happens if you have this kind of sustained thing going on in this fusion reactor, sorry, then essentially if things go out of hand, then it just sort of dies off and cools off. Like, it can't happen some meltdown or something like that, doesn't happen. So this is what people are working on, many different ways how to achieve it. There is one giant collaboration being done. It's called the ITER, and this is by Europe and China, United States, Russia, South Korea, India, many countries in there, all collaborating, which is wonderful to see. Countries that normally wouldn't, even have a normal conversation with each other, now working together to create potentially unlimited energy. And what their goal is with this, essentially what they needed from these fusion reactors, all reactors before were too small, so essentially what they needed to do is create something bigger, and that can sustain the reaction for much longer, and they're expecting it to produce for every 1 megawatt you put in, you get 10 out. So 1 to 10 ratio of producing energy. Now this one, they say it will be in working order in sometimes 2020s. Hopefully it takes less than that. That one that they're building is an experimental version, and so other ones have to be built. That takes a long time to actually produce any usable energy, but hope would be that technology as we see around us is advancing at an exponential rate, so by the time they already see that this works, we have much better manufacturing and building methods. The way that they're building it now, they have different parts coming from different countries. Like, you have one large magnetic coil that's supposed to hold the hot fusion plasma in one place. One is built in China, another one is built in USA, and they all have to be exactly the same measurements. So there's incredible bureaucracy and politics of how exactly to the parts from where, and everybody wants to do their own part as well. What's wonderful about it is that everyone taking a part in this gets all the patents, so everyone working on this, all these countries, know how to make them once we finish this project. If one learns something new, they all do. So we all as a humanity benefit, and I think we should have way more, kind of scientific sort of goals like this for humanity, for our entire species actually. So this is nice to see. Nuclear fission, what we do right now, it's actually not as bad as people say. Like, there are a lot of nuclear fission reactors around, and it only takes a few to explode or whatever, which is horrible, and people say, oh, this is so bad, but like hundreds and thousands of them work perfectly and nothing happens. Only few big disasters that have happened. Of course, it's horrible, and in no way should we be like, oh, that's fine, few can happen. We should definitely work on the safety, but considering that we're burning coal that's continuously polluting the planet and all of this stuff, it's really not as bad as a monster as it's made out to be. The waste is a bad part, and if something goes wrong, it's bad. But in general, it's quite efficient. It's a good way of producing energy, relatively speaking. So fusion, something we're going towards. It would be really nice to have it. So just a short overview of nuclear fusion versus nuclear fission. Fusion we have, fusion we're working towards, and hopefully this will be the future of energy. Once we get these reactions going, they can be self-sustainable and produce potentially limitless amount of energy, because all they need essentially is water, and we have quite a lot of water on our planet. So hope you got something out of this video. Thank you so much for watching, and take care.